students, today's agenda is to check homework. We'll be learning about dependent and independent events, and you will be able to do 5.2. Today, students will be able to determine whether events are independent or dependent. And they will also be able to find and compare probabilities of independent and dependent events. And for the first ones, all we're going to do is write independent or dependent and explain why. We don't actually need to find the probability of these events occurring. You roll a die and spin a wheel. Event A, you get a 2 on the die. Event B, you get green on the wheel. Well, when you roll a die, it will not affect what you get on the wheel. Let's pretend that you have 4 different colors. You might have red, green, blue, yellow on the wheel, and it doesn't matter what you get on the die. You might get any of the 4 colors on the wheel independently of what you get on the die. So all you have to do in here is independent, and the reason is because event A does not affect event B. Okay, let's go to another one. Okay, for number 2, it says you have 4 sheets of shiny paper to create a scrapbook. They are 2 red and 2 pink. You choose one at random, then a second one. Event A, you choose a pink sheet. Event B, you choose a red sheet. Well, once you use the first sheet, then you're not going to have it. So that means that they're dependent. Why? Because once you use one, there's less sheets to choose from. You still have 2 red ones to choose from, but there is a total of 3 instead of 4 shiny sheets of paper. So this is dependent. And the reason is because you will have less sheets to choose from. And the probability will actually affect on the second one. Number 3 says you have a deck of 52 cards. You get 2 cards without replacing it, meaning without replacing the first one. Event A, you get a face card first. Event B, you get a 7th second. Since it says without replacing the card, that means that you have less cards. Once you choose the first one, there are less cards to choose from, and so that will affect what you get for the second event. So we're going to say that this is dependent. And again, not replacing the card. Without replacing it, it means without putting it back into the pile of 52. Now, for the second chance, you only have 51 cards. Not replacing the card after the first draw affects the chances for the second one. It doesn't fit in here. Let me put it on the side for the second event. Okay, for number 4, pretend that this is a fair wheel, that all of them have the same amount of space or area, and so they have the same chances of getting to any of these numbers. So what is the probability that you get a 4 first when you spin this wheel? A 4, how many 4s do we have? There is only 1. So 1 out of how many total? There are 5 possible outcomes. For the second event, it says, what is the probability that you get a number greater than 2 for the second time you spin it? So a number greater than 2 does not include 2. Okay, it says greater than 2, so that will be 3, 4, and 5. So it will be 3 out of 5 possible outcomes. When it says probability of getting a 4 first, this is just looking at the probability of that happening. And this is the probability of this event happening on its own. But now it says find the probability that you get a 4 for the first time you spin and a number greater than 2 the second time you spin. So this symbol, which is a backwards U, represents the word and it's called joint probability. And as you can see, the second event is not affected by the first one because you still have a 4 in there. You still can choose from it. It's not like when you remove it, okay? Like we've said before in the deck of cards. So because it doesn't affect it, then we say that this is independent. Independent probability. Okay, so these two events are independent of each other. And when we are trying to find joint probability, what you have to do, it doesn't matter if it's independent or dependent, what you do is multiply the two probabilities that we got for each event. Okay, so for this event is 1/5 times the probability of getting a number that is greater than 2, which is 3/5. And 1 times 3 is 3. And 5 times 5 is 25. We cannot simplify that. However, we are going to find this as a decimal and then as a percent. When we're finding a decimal, all you have to do is divide the numerator by the denominator. So 3 divided by 25. 3 divided by 25 is 0.12. And for the percent, all we have to do is move the decimal to the right. 2 spaces only. Always only 2 spaces. So 1, 2, that's going to be 12%. So what is the probability that I get a 4 for the first spin and a number greater than 2 on the second spin? Well, the probability is 3 over 25, which is equals to 0.12, which is equals to 12%. Number 5 says, you have a deck of 52 cards. You get 2 cards without replacing the first one. If you're not familiar with the deck of cards, I explained it in 5.1 with a lot of detail and I showed the cards. So you might want to go and look at that after watching this video if you want to familiarize yourself more with the 52 cards, the deck of 52 cards. So we know that there is one ace for each of the 4 different shapes, spades, hearts, diamonds, and clubs. So that means that there is 4 of them. So 4 out of 52. When it says without replacement, that means that you don't put back the card that you chose. So now we know that there is going to be one card less than we had before. So instead of 52, now we only have 51. What does that mean? It means that there is less chances for the second event to happen. Now you only have 51 cards. So this is the tricky part. Let's look at what it says. For the second event, it says, what is the probability that you get a number less than 7 for your second draw? Now, be careful because this is ace, but it's also considered a number 1. So that's included in here. So what numbers are included when it's less than 7? Well, in each shape, you have the ace, the 2, the 3, the 4, the 5, and the 6. The 7 we do not include it because it's less than 7. So in each shape, you have 6 numbers. That means since there are 4 shapes, right? There's the diamond, whoops, the hearts, which are red. Both of these are red. You have the clubs, and you have the spades. Whoops, like that, something like that. These are black, these are red. Since you have 6 in each one, that means 4 times 6 cards. The 1, the ace, the 1, the 2, the 3, the 4, the 5, and the 6. Okay, we multiply those, and those are the chances that you have of getting that for your second card. Well, 4 times 6 is 24. However, I want you to notice something. I just multiply this, But what's my mistake here? I'm not replacing the card. That means that there is one less. Let's say that I took one card. One of those cards, let's say that I got an ace. I need to remove a 1 in here too. So it shouldn't be 24. It should be 23. Okay? So instead of 24, it's 23. Again, why? Because this is included in the numbers that we can select in the second event. Again, for the first event, I either got a 1, an ace, actually, an ace of either a diamond, an ace of clubs, only one, not all of them. Hearts, clubs, or an ace of spades. Sorry about my shapes. So I got one of them. There is 4 chances that I get it, that I get an A for the first, but I only got one out. I chose one out, didn't replace it, and chose the second card. That's why I only take away 1, not 4, but only 1, because I only chose one card on the first event, okay? Knowing that information, what is the probability that you get an ace first and a number less than 7 second? You can either simplify your fraction over here or you can do it over here. We know that these numbers are divisible by 4. And usually when you work with cards, you will be dividing by 4 a lot. So 4 divided by 4 is 1. 52 divided by 4 is 13. So that's my probability of getting an ace. Again, you could do it here or you could probably do it here too. So again, is this dependent or independent? Well, this is a dependent event. Why? Because the chances change after the first event, the chances of the second event change, okay? So this is dependent. The chances of getting a number less than 7 for the second card depends on what I get on the first one. Okay, having that in mind, it doesn't matter if it's dependent or independent. For joint probability, meaning and, the word and, you always multiply, okay? So the probability of choosing an A first is 1 over 13 times the probability of getting a number less than 7 for the second card is 23 over 51, not 24, 23 over 51. And for multiplication, you just multiply straight. 1 times 23 is 23. 13 times 51, I'll just use my calculator. 13 times 51 is 663. In decimal form, all you have to do is divide 23 divided by 663. So it's 0.035. Around, I'll use 3 digits, and then the fourth one tells me, since it's bigger than 5, so 5, 6, 7, 8, or 9 will give one more to this one when you round. And then you move it 2 spaces for the percent, so it's going to be 3.5%. And for probability, or when you round, you might use this, which is about. This means about. So in here as well. Again, it doesn't matter. For joint probability, you always multiply, even if it's dependent or independent. What did we say with replacement? You choose one and then you put it back. Let's do that. Just pretend that it says with replacement. This is just an extra. So the probability of getting an A first doesn't change. There are 4 aces in the 52 cards, and if you replace it, the probability of getting a number less than 7 second for the second card, well, you're putting it back, so there are 52 cards again, and Since you're putting the card back, there's also four shapes, and each shape you will have chances of an ace, a 2, a 3, a 4, a 5, and a 6. So that's, now it is 24. You don't need to change this one or this one. Sometimes in probability you need to change only this one, but not this one, because it doesn't affect. If I said a number greater than 7, it wouldn't affect because this is less than 7, not greater. So it would affect this one because you don't replace it up there, but it doesn't affect on the top. So by replacing it, by putting it back, it goes back to the original probability of getting 24 out of 52 are less than 7. Okay. So for the probability of A first and a number less than 7 for the second, whoops, then it's going to be 4 over 52 times 24 over 52. You can always simplify across and across, or you can simplify as a fraction independently, like each fraction. So let's do it across, just so that, because many are used to that. So divided by 4, that's equals to 1. Divided by 4 is equals to 13. In here we can also divide by 4. So this is 13, and this will be 24 divided by 4 is 6. Now we can multiply straight. 1 times 6 is 6. 13 times 13 is 169. And when we divide, I can barely see, 6 divided by 169 equals 0.036. Why 6? Because the 5 gives 1 more. Remember, if this is 4, 3, 2, 1, or 0, it doesn't give anything to the previous number. But if this is a 5, 6, 7, 8, or 9, then this goes up 1. We move it 2 spaces, and so it's 3.6% chances that I will win. So again, I forgot to put about. When we round, we can use this symbol instead of putting equal. It just means about. Okay, notice how by replacing the card, you get a little bit more chances of winning than with the same event, but by replacing it, you get a little bit more of a chance to win when you replace it. For number 6, it says you roll a die and flip a coin. Determine if the following event is dependent or independent, and then we're going to solve it. Well, because it doesn't matter what you roll on the die. It won't affect the outcome of the coin. Well, it doesn't matter, then that means that it's going to be independent. So let's break this apart. The probability of getting a 3. Well, there is these dice, looks like it's 6-faced. So it's going to be, how many 3s are there? Only 1. How many faces? 6. What is the probability of getting heads? Well, there is only 1 heads out of the 2 different faces, different outcomes. The other one is tails, so it's 1 out of the 2, which is heads and tails. Well, the probability for both, all you have to do is multiply. So 1/6 times 1/2. We multiply straight because we cannot simplify. So 1 times 1 is 1. 6 times 2 is 12. To get it into decimal, all you have to do is divide. So 1 divided by 12 equals 0.083. The 3 does not give anything to the 3 here. Notice how we're rounding to the thousands, and the 10,000s is the one that is deciding whether you round up or stay the same. We move it 2 spaces, and that's going to be 8.3%. Again, about 8.3. With this, we end our lesson. If you can please give us a thumbs up, subscribe around here. This is the link to the entire unit. Here you will find the next lesson. Now you're able to do 5.2 and have fun.